Every year, billions of banana trees are cut down, not because they failed, but because their job was finished. We see the fruit. We eat the fruit, and then we walk away, leaving behind something most people never think about. A structure taller than a person, heavier than it looks, filled with water, filled with fiber. For decades, it was treated as waste, left to rot, burned, forgotten. But today, inside high-tech factories, that discarded plant is being transformed into textiles, into rope, into industrial materials shaping a more sustainable future. This is not farming. This is not recycling. This is industrial engineering hidden inside a banana tree. Welcome to a factory you've never seen before. Bananas are one of the most consumed foods on Earth. They travel across continents. They support millions of farmers. They move through one of the largest agricultural systems in the world. But once the fruit is harvested, something remarkable happens. The plant is cut down, not because it failed, not because it was damaged, but because its purpose, at least as we understood it, was complete. What remains is a towering structure, tall, heavy, filled with water, layered with natural strength. For decades, this part of the banana plant was ignored, left in fields, burned, returned to the soil. Not because it had no value, but because we didn't yet know how to unlock it. And this is where the story changes. Because sometimes, progress doesn't come from inventing something new. It comes from finally paying attention to what was already there. Hidden inside this plant is a natural fiber, strong, flexible, renewable, waiting for the right moment, the right technology, and the right way of thinking. This is a story about that shift. A shift from disposal to design, from agriculture to engineering, from waste to possibility. And it begins in a place most people never look, inside a banana tree. At first glance, a banana tree looks strong, tall, solid, almost wooden. But it isn't a tree at all. What we call a banana trunk is actually something entirely different. A structure known as a pseudostem. It isn't made of wood. It doesn't grow in rings, and it isn't designed to last for years. Instead, it's built for speed. Layer upon layer of tightly wrapped leaf sheaths rise upward in a matter of months, forming a column strong enough to hold heavy fruit and flexible enough to bend with wind and rain. Inside, the structure is rich with water, often more than 90% by weight, and running through it all are long, continuous cellulose fibers. These fibers evolved for one purpose: to support life quickly, efficiently, and naturally. But that same biology is what made banana stems difficult to work with. Too wet for traditional cutting machines, too soft for conventional fiber processing, too heavy to transport without losing structure. For a long time, the banana pseudostem sat in between worlds. Not wood, not straw, not suitable for the systems we already had. And so it stayed in the fields, until engineers began to see it differently. Not as a problem, but as a material with rules of its own. Rules that required new machines, new pressures, new ways of handling moisture, movement, and time. Understanding the banana plant was the first step toward transforming it. Because before you can change a material, you have to respect how it works. Everything begins with timing. Once a banana plant has produced its fruit, its role in the growth cycle is complete. There is no second harvest, no waiting for next season. The plant must come down. But this moment, the moment after harvest, is where possibility opens. Fresh banana stems are heavy with moisture. Their fibers are still long, intact, and strong. And the clock has already started. Too much delay, and the material begins to break down. Too much damage, and the fibers lose their strength. So harvesting for fiber is not about speed alone. It's about precision. Workers cut the pseudostem carefully, keeping the structure as whole as possible. They move it quickly, not to rush the process, but to protect the material. This is not waste collection. It is raw material handling. Every cut, every lift, every placement affects what the fiber can become later. And because banana stems are heavy, wet, and flexible, they challenge traditional logistics. They can't be stacked like timber. They can't be dried in the field. They can't be treated like ordinary agricultural residue. Instead, they must be moved with intention, from plantation to processing, before biology takes over. In this brief window, agriculture hands the material to industry, and what happens next depends entirely on how well that handoff is done. When banana stems arrive at the factory, they are still changing. They are wet, they are flexible, and they are alive with biological activity. This is not a material that can wait. The first job of the factory is not to process, but to understand. Each stem is inspected, its size, its freshness, its condition. Not all material is the same. Some stems are too degraded, some too damaged. Others are perfectly suited for fiber extraction. This early decision protects everything that follows. From here, the stems are guided onto heavy-duty conveyors, designed for a very specific challenge: moving soft, slippery, water-rich material. Without tearing it apart, moisture is managed immediately. Excess water is allowed to drain. Surfaces are kept clean. Movement is controlled. This is where the factory reveals its purpose. It doesn't force the material to behave like wood. It adapts to how the banana stem actually behaves. Pressure replaces impact. Alignment replaces speed. And patience replaces brute force. Before a single fiber is separated, the plant is prepared. Not rushed, not stressed, but guided forward. Because with materials like this, the quality of the beginning determines everything that comes next. Before fibers can be extracted, the structure holding them together must be carefully opened. This is where mechanical splitting begins. The banana pseudostem is not crushed. It is not chopped into pieces. It is split lengthwise. That detail matters. Inside the stem, fibers already run in long, continuous lines. Cut across them, and they shorten. Pull too hard, and they tear. So the machines here do something very deliberate. They guide the material forward, apply controlled pressure, and separate the stem along its natural direction. Blades and rollers work together, not to destroy the structure, but to reveal it. As the stem passes through, it opens into long strips. Moisture is released, inner layers are exposed, and suddenly, the material begins to change. What was once a solid water-heavy column becomes something flexible, organized, and readable. This step is about respect for structure. The machines are tuned carefully. Too much pressure, and fibers are damaged. Too little, and the stem resists separation. Operators monitor the process constantly, adjusting speed, tension, and alignment. Because this is the moment where raw biology starts to become an engineered material. Not through force, but through precision. And once the structure is opened, the fibers inside are finally ready to be set free. With the structure opened, the real work can begin. Inside each split stem are long strands of natural fiber, strong, flexible, and tightly bound to softer plant tissue. The challenge now is separation, not by tearing, not by grinding, but by removing what the fiber doesn't need. This process is called decortication. As the material moves through rotating drums and pressure surfaces, the softer pulp begins to give way. It peels back, it falls away, and what remains is the fiber itself. Long, continuous, still wet, but intact. Water flows through the system, carrying away sugars, sap, and residual plant matter. Nothing here is rushed. Speed is balanced with control. Force is applied gradually. And every adjustment protects the length and strength of the fiber. Operators watch closely, not just for output, but for consistency, because this is the moment that defines the material. Once separated, the fiber is no longer part of the plant. It has crossed a boundary from biological structure to industrial resource. And with that transformation complete, the focus shifts again, from extraction to refinement. Freshly extracted fiber is strong, but it is not finished. It still carries moisture, traces of pulp, natural sugars from the plant itself. To become truly usable, the fiber must be cleaned and stabilized. This is where washing begins. Water moves gently through the fibers, not to strip them aggressively, but to rinse away what no longer belongs. Sap dissolves, fine plant residue separates, and the fibers begin to change, becoming lighter, cleaner, more distinct. At the same time, the process is carefully controlled. Too much agitation, and fibers tangle. Too little movement, and impurities remain. Every channel, every spray, every flow rate is designed to protect alignment while allowing cleanliness. Once washed, the next challenge is moisture. Water must be removed. Slowly, too fast, and fibers become brittle. Too uneven, and quality suffers. Warm air circulates. Humidity is measured. Time does its work. This stage isn't dramatic. It's deliberate, because stability is what allows fiber to last. To be stored, shipped, woven, twisted, and used again and again. Here, the fiber finds balance. Not wet, not dry, but ready. Once the fiber is cleaned and stabilized, it's tested, stretched, handled, measured. Only material that meets industrial standards moves forward. The rest is returned to the system. Nothing wasted. Approved fibers are aligned, bundled, and prepared for shipment. Not as waste, not as byproduct, but as a material with purpose. From here, banana fiber travels far beyond the plantation, into textiles, into rope and cord, into composite materials designed for strength and sustainability. What was once left behind in the field now supports new industries, new products, and new ways of thinking. This transformation didn't happen overnight. It required understanding biology, respecting materials, and building machines that work with nature, not against it. The result is more than fiber. It's a system where agriculture and industry meet, where waste becomes resource, and where progress is measured not only in efficiency, but in intention. Because sometimes, the future isn't about creating something new. It's about finally recognizing the value of what was already there.
The moisture levels are fluctuating more than expected in Sector 3.
Yes, but throughput remains steady. We should monitor the efficiency metrics closely.
By utilizing banana fiber, we've developed incredibly fine textiles and these reinforced structural panels.
We're sending this shipment out now. It's amazing what we can make from the waste.